Good day, everyone. We are going to present our project called the 3-bit adder subtractor circuit. This circuit can perform both addition and subtraction using the same components. In our setup, we built the circuit on a breadboard, soldered the wires, and placed everything inside the box to make it neat and organized for our final presentation.
In this group, we completed the necessary equipment and we wired it on the breadboard and we analyzed our output carefully so that our project would come out well. Also, we started by setting out two dip switches, one for input A and one for input B. Each switch has 3 bits labeled A0 to A2 and B0 to B2. Those switches represent binary numbers from 0 up to 7. In the middle of the circuit, we place and toggle the switch that controls the operation. Which the switch is turned off, the circuit performs addition. Which is turned on, it performs subtraction. The signals from the dip switches go into a SOR gate IC. This IC prepares the B input. When the operation switch is set to subtraction, the SOR inverts the B bits. This is how the circuit creates the two complement, which allows subtraction to work just like in addition. After that, all the bits are sent to the 74LS83 full adder IC. The 74LS83 takes the 3A bits that modifies B bits and the carry input from the operation switch and then adds them together and produce 4 outputs S0, S1, S2, and S3 which represent the binary result. Those outputs are connected to BCD, the 7th segment decoder IC, which converts the binary output into a readable number of a 7th segment display. So when we flip the dip switches, we can see the values of A and B. And when we change the operation switch, the display switches between addition and subtraction results. Although the circuit mostly works and doesn't fully function correctly because of some factors such as loose wiring, breadboard limitations, and voltage inconsistencies between ICs, those can cause certain LEDs or segments to light up incorrectly. Despite those issues, the circuit still demonstrates the main idea of how binary numbers can be added or subtracted using digital logic. It shows the basic concept of how computers perform arithmetic operation at the hardware level. However, it is still more ideal to use a 4-bit design instead of 3-bit. A 4-bit adder allows larger values to be displayed correctly and reduces logic errors. Our 3-bit adder and subtractors successfully shows how simple logic ICs can work together, from switches and gates to adders and displays, to form a working digital calculator circuit.